to preserve, transmit, and extend knowledge. This is a major purpose of an institution of higher education. At Rensselaer, scientific research and development are basic to this purpose. For example, in nuclear engineering, upper atmospheric physics, magnetoplasma dynamics, interdisciplinary materials research, and the exploration of hypersonic phenomena. Both faculty and staff are finding ways to improve the effectiveness of our instructional programs. Among our educational research and development projects have been experiments in class size, the production and use of films, the use of the overhead projector in physics lectures, the design of classroom facilities, as well as closed-circuit television, which was first used at Rensselaer in teaching our strength of materials laboratory. In this project, we found the principal value of the television method is that it can make information which normally would be accessible to few available to many. From this initial experimentation and evaluation has evolved a modern closed-circuit television system with viewing facilities in several classrooms throughout the campus. An introductory course in psychology is an example of its present application. Here, the privacy of the TV studio, for example, allows the instructor to conduct experiments and demonstrations involving human beings or animals, which would be difficult to present under customary large class conditions. This recording of the televised picture, as seen in the classroom, shows a student with a rat he is trained to traverse a maze for a reward of food. However, television is only part of a continuing program to explore the application of newer media in a variety of teaching situations at Rensselaer. Many of our educational experiments draw upon these newer educational media. In each case, the instructor must ask what combination of teaching materials and techniques will help him reach his students with the greatest impact. To arrive at a solution to this question, a professor and a member of our institutional research staff work cooperatively. The former with an intimate knowledge of the problem and subject matter, the latter with a wide array of technical aids to draw upon. After a professor actually uses these materials, he may wish to revise them until he is certain that an optimum design has been achieved. The application of technological devices to our instruction is best illustrated through Rensselaer's experimental classroom, a result of preliminary studies by the School of Architecture on the design of auditorium studio facilities for engineering education. The classroom's primary design feature is its incorporation of systems for instructional media, such as front and rear screen projection for slides and films, and TV monitor and projection viewing. In this instance, a class in embryology observes a motion picture of the development of the heart in a chick embryo. Later, in the laboratory, living specimens will be used to illustrate the principles observed. With the overhead projector, colored diagrams are used to describe the functions of the various parts of the embryo. Histological details of the chick embryo and its sequential development are presented through automatic slide projection. The use of models permits the visualization in 3 dimensions of structures that were described earlier with the use of film, the overhead projector, and slides. Closed-circuit television is utilized to present microscope slides of serial sections of an embryo. The professor can show, with the aid of different magnifications, a variety of histological details. Progressing from section to section, answers to detailed questions relating to specific areas of the slide can be given. Information communicated through these many media is thus integrated logically and sequentially. The student is thereby helped to grasp more quickly the true structure of the subject he's studying. To create these instructional aids requires a variety of specialized production facilities and personnel. for example, in motion picture production. As a pure recording mechanism, or as a means of interpreting and conveying ideas and concepts, the motion picture medium is being thoroughly explored for its many educational applications. For example, the motion picture Satellite Orbits, produced in cooperation with the Department of Physics, demonstrates orbital motion through the use of models and animation. This particular sequence presents Kepler's second law, the law of equal areas, and Kepler's first law, the law of orbits, as they apply to orbital motion. The two laws explain why a satellite maintains an elliptical orbit above the Earth. The film is used as a summary of the concepts of orbital motion in our basic physics course. The Department of Chemistry has developed several films in the area of qualitative and quantitative analysis. Gas chromatography, part of a series on physical methods of chemical analysis, is used in the instrumental analysis course to review the overall field of gas chromatography once the material has been covered by lecture and laboratory practice. In detail, we see how the carrier gas, chromatographic columns, detectors, and a recorder are combined in a laboratory tool used for the measurement of a composition of matter. A still life, interpreted by 3 artists, is the subject of a film in the humanities entitled Representation and Design. It is one in a series of 5 films produced in cooperation with the Department of Language and Literature that explore different ways of presenting nonverbal languages such as painting, sculpture, and music, as well as verbal language. The film emphasizes the internal demands of the developing picture as the governing principle in its composition. Thus, the student observes the development of a statement through a nonverbal language and experiences vicariously the creation of a work of art. In this combination of excerpts, we see the development of an abstract design, a non-objective composition, and a representational painting that result from each artist's interpretation of the subject. These experimental activities in education are representative of Rensselaer's effort to increase the effectiveness of our instruction. Our results are available to other colleges and universities, as well as many of the educational materials which we produce. Also important in our institutional research effort is the statistical analysis of instructional programs. To ensure each individual his greatest opportunity to be as productive as possible, an institution must operate efficiently. For this, quantitative information is needed. Therefore, we collect data on course enrollments, manpower in teaching and research, and the utilization of facilities. This information is analyzed not only for an understanding of day-to-day operations, but for projecting present trends in order to estimate the probable requirements of the future, such as those related to the growth of disciplines, new classroom and laboratory space for teaching and research, and more professors to teach tomorrow's youth. Representative of these developments is this class in reactor physics, shown in the process of unloading a subcritical nuclear reactor. These trends reflect, among other things, a need for continued effort in examining the educational process, continued experimentation with aids and facilities in teaching, and perhaps with learning devices as yet unknown, and further development of the statistical analysis of instructional programs. These and other needs point to a future of educational innovation based on operating efficiency, forward planning, and new knowledge of how students learn. With this in mind, our president, Dr. Richard G. Folsom, sums up our total institutional research effort in saying,
"We are seeking better ways to provide an exceptional educational experience for each and every student. While doing this, we also accept our obligation to educate as many students as possible that is within our resources, as long as we continue the achievement in selected programs and exceed or equal our present standards. Both quality and quantity are basic to the development of an optimum Rensselaer educational experience. And in fact, from the time of entrance until graduation, a student's total learning experience is Rensselaer's contribution to the education of men and women for the constructive leadership in our society.